Hi guys, this is just a quick video about the axiom schema of comprehension again. Okay, so kind of the point of this axiom is that we want to be able to use this notation, and to use this notation we need for this set to exist, and we need for it to be unique, so we need this to define only one set, you know? So the axiom schema of comprehension tells us that if A is a set and P of X is a property, then there is a set B such that X is in B if and only if X is in A and P of X. That's what the axiom schema of comprehension says. And so that means like this kind of, that proves that axiom tells us that this set exists, and then we just want to see that it there's only one set like that. Okay, so that's why we have this proposition. So let A be a set and P of X be a property. Then suppose that we have sets B and B prime such that X is in B if and only if P of X, and X is in B prime if and only if P of X. Okay, so under those assumptions, then B equals B prime. And so this set B and B prime, these would be given by the axiom schema of comprehension. And then this proposition tells us that these sets are actually equal. And then that justifies this notation, because now when I write down this notation, it is referring to a thing that exists, and it is referring to like one thing, you know, a unique set like that. Okay, so let's prove this proposition. Okay, so our assumption is that we have this set B and B prime, but if we just combine these two, they're both if and only if statements. We see that X is in B if and only if P of X, and P of X if and only if X is in B prime. So we have X is in B if and only if P of X, this is by part A, by assumption A, and by assumption B, P of X if and only if X is in B prime. Okay, therefore X is in B if and only if X is in B prime. So therefore B and B prime have exactly the same elements. And therefore B equals B prime. That is the axiom of extension. QED. Okay. So now when we see this notation, we don't have to worry about there being, you know, more than one possible set that satisfies this notation. There's exactly one. Okay, so that's going to be the end of this video. See you next time.